Hello everyone, good day. Today I'll make a tutorial video on how to use Jamovi in solving for the independent sample t-test, paired sample t-test, Anova, Pearson'S R, simple linear regression, and multiple linear regression. So here is our data. As you can see, we have the gender data variable, program, mathematical creativity pretest, and post-test, interest in business, product acceptance, time spent on reading reviews, mathematical competence, and product satisfaction. So the first thing that we will calculate is person R, how to use person R in Jamovi. So click this regression and click correlation matrix. So in solving the person, the data should be in continuous or ordinal. So in here, let's try to find out if there is a relationship between interest in business and mathematical competence. If our interest in business is high, will that also mean that our mathematical competence is high? So let's look at the result. So in here, our correlation is 0.347, and this means a weak correlation. However, it is fine since our p-value is lesser than 0.05, which means that there is a significant relationship between the interest in business and mathematical competence. It means that if our interest in business is high, then our mathematical competence is also high. So in here, we reject the null hypothesis. So next, let's compute for the linear regression. So click again the regression, and this time click the linear regression. So in here, as you can see, we have the dependent variable, the covariates, and the factors. So covariates are the independent variable that is continuous, and the factors are the nominal independent variables. So let's see. Our independent variables is interest in business, and our covariates is mathematical competence again. So our model fit measures the R squared result is 0.1 to 1, and if this is multiplied by 100, then the result will be 12%. That means that 12% of our mathematical competence can predict in our interest in business. And in here, let's look again for the p-value. So as you can see, our intercept and the mathematical competence are both lesser than 0.05, which means this is significant. There is a significant association between the interest in business and mathematical competence. So let's do the multiple linear regression. So the difference in multiple and linear regression is that in multiple regression, we have a more than one independent variable. So let's do two covariates, and the second one is mathematical creativity post-test, and our factors is gender. So as you can see in our R squared, we have 0.300, and if this is multiplied by 100, then we will get 30%. And this means that 30% of our dependent variable, which is interest in business, can be explained by the combined power of our independent variables, which is the mathematical competence, mathematical creativity post-test, and gender. So again, let's look for the p-value to see in which of this has the significant effect. So as you can see, mathematical competence and mathematical creativity post-test has the significant effect since both are lesser than 0.05, and our gender has no significant effect in our dependent variable, which means that regardless of the gender, it will not affect its interest in business. So in here, we have the dependent variables and grouping variables. Note that we can have more than two dependent variables. So let's click the interest in business and mathematical competence. So let's try to find out if there is a significant difference in interest in business and mathematical competence if they are grouped by gender. So we can see in our p-value, our result is greater than 0.05, and this means there are no significant um, difference. So we failed to reject our null hypothesis. So next, let's do the paired sample t-test. So again, let's click the t-test and click the paired sample t-test. So from the word paired, that means we only have one group or same people. So in our data, we have the mathematical creativity pre-test and mathematical creativity post-test. So our p-value here is 0.589, which is greater than 0.05. So again, it means that there is no significant difference between our mathematical creativity pre-test and mathematical creativity post-test. Let's do next the one sample t-test. So again, click the t-test and click this time the one sample t-test. So let's say we have the dependent variable interest in business. So again, look for the p-value, and our p-value here is lesser than 0.05. So this means that there is a significant difference in our interest in business. So this time, let's compute for the ANOVA. So click the ANOVA and click this ANOVA. So let's say this time our dependent variable is mathematical competence. And our fixed factors should have more than two groups. And in here, we have the time spent on reading reviews. So as you can see, our p-value here is lesser than 0.05, which means that there is a significant difference in our mathematical competence if they are grouped by time spent on reading reviews. So we can say that those who have a higher time spent on reading reviews has a higher mathematical competence. So that is all for today. I hope that you have learned something new, or I'm able to help you in terms of competing for the person R, linear regression, multiple linear regression, the t-test, which is the independent t-test, paired t-test, one sample t-test, and the ANOVA. So thank you for today. Goodbye.